5,500 to 5.5 million degrees. That extreme heat triggers the solar wind, sending millions of tons of particles streaming out into space. The bigger the star, the more deadly the wind.
If we were orbiting a star like Eta Carinae at the same distance, it would be hell on Earth, quite literally. The amount of energy blasting down on the Earth would strip away our atmosphere, boil our oceans, melt the surface.
Understanding how stars work could help us protect ourselves by predicting their most destructive forces. But the giant red star is self-destructing. Its core becomes dangerously unstable. Slowly, it disintegrates. The star is dead. All that remains is an intensely hot, dense core. The red giant has become a white dwarf.
By the time a star reaches the white dwarf stage, the fusion process has stopped. The engine has finally come to rest.
Our sun will end its life as a white dwarf no larger than the Earth, but 1 million times denser.
A white dwarf is a pretty amazing object. It's incredibly dense. If you could take a sugar cube-sized chunk of white dwarf and put it on the surface of the Earth, it would be so dense it would fall right through the ground.
At the heart of a white dwarf, astronomers believe there's a giant crystal of pure carbon, a cosmic diamond thousands of kilometers across.
The idea that the sun will become this sort of cool, dark lump of cinder material is kind of sad. But that really will be sort of a trillion carat diamond. Think of that, a diamond in the sky.
Giant stars live fast, burn bright, and die hard. But from their destruction comes life. The death of massive stars creates the building blocks of the universe, the seeds of life itself. Less than 600 light-years from Earth, the monster star Betelgeuse is near death, in space terms at least. It's younger than our sun, millions, not billions of years old. But the fusion at its core is far more intense.
Betelgeuse is a different beast from the sun entirely. It's a red supergiant. And the reason is because Betelgeuse is more massive. It has 20 times the mass of the sun. And that means what's going on in its core is very different than what's going on in the sun's.
Massive stars generate pressures and temperatures greater than anywhere else in the universe.
There are many ideas about what a star killer machine might be like. Strangely enough, it's as run-of-the-mill as something as iron.
To a star, iron is the most dangerous element in the universe. It's poison. It's trying to dump energy into that iron ball and trying to make it fuse, but it can't.
Telescopes around the world scan the skies for supernovas. In 1987, a brilliant kilometers wide, hurtles out into space. But there's no record of the actual moment of death, when the star first ripped itself apart. Supernova.
What's amazing when these stars explode is that they almost turn inside out. Explodes. Working with these tools is the most exciting thing I can imagine doing.
This massive machine amplifies the power of a single laser beam 1,000 million times. And all that energy will be directed toward an area the size of a pinhead. Think of this tiny target as a star's core. The laser simulates the most violent explosion in the